Good morning, everyone. This is the Q&A session 2 from the playlist of JEE Advanced. The topic is dimensional analysis, and this session is in continuation of the session number 1. In the session number 1, we have solved one question from the same topic which was asked in the advanced paper. And today also I have taken the same topic here, and the purpose of taking this question was to just intimate you that in JEE advanced paper questions, sometimes or even many a times the question which were asked in these paper are also very easy. This is a very easy question. So the very purpose is to just intimate you that even in the JEE papers the questions are very easy. The only thing is that your concepts should be very clear. If your concepts are clear, you can solve this question in a couple of minutes. So here there is written that in a system of unit, mass and angular momentum are dimensionless. So if the dimension of the length is L, then which of the following statements are correct? So we have to find the correct statements from these four, and so there is a probability that maybe one or more than one statements might be correct. So here mass and angular momentum are dimensionless. Dimension of length is given as L, then which of the following statements are correct? So here angular momentum का जो dimension है वो angular momentum is dimensionless. Now angular momentum is given by angular momentum is equal to mvr, and this is also equal to I omega. So we can use any of these two formulas here in order to proceed further. So the dimension of angular momentum as per this formula will be what? In this, the dimension of mass, I will be taking this formula now. See, the dimension of mass is m. The dimension of v, that is velocity, is equal to L t minus 1, I think, okay. And the dimension of r, which is the radius, so this is also equal to L. So the dimension of angular momentum is will be given by m L square t minus 1. Now in the question it is written that the dimension in a particular system of unit, the mass and angular momentum are dimensionless. So this angular momentum is dimensionless. Here mass is dimensionless. Here mass is dimensionless. So it implies that angular momentum will be dimensionless when L2 t minus 1 is dimensionless, when L2 t minus 1 is dimensionless, because it is given that in a particular system of unit mass is dimensionless. So if mass is dimensionless and angular momentum is also dimensionless, it means that L2 t minus 1, it should also be dimensionless. Now if this is dimensionless, then if L2 is dimensionless, then if L2 t minus 1 is dimensionless, then t to the power minus 1, the dimension of this should be equal to L to the power minus 2, because if t to the power minus 1 is equal to L to the power t minus 2, then the dimension of this will be L to the power 2 uh, into L to the power minus 2, and this will become dimensionless. So it implies that the dimension of t should be equal to L square. So from uh, these two conditions, that is mass and angular momentum are dimensionless, I have found the dimension of t which is equal to L square. Now question is, it's now very simple. You have to find a dimension of all these four parameters, and we will be able to find the correct alternatives. So the dimension of force. Force is equal to mass into acceleration. Mass into acceleration. So I am just writing it here in short. So the dimension of mass is m, and the dimension of acceleration is L t minus 2. Now here mass is dimensionless in a particular system of unit. So the dimension of force will be equal to L. Now T is equal to L square. So T minus 2 will be equal to, this will be, if I just substitute the value of this T minus 2 from this equation, so I will be getting it as L, this will be equal to L minus 4. So this will be equal T minus 2 will be equal to L to the power minus 4, and so I will be substituting that value here. So I will be getting L, this is to the power 1, and this is L to the power minus 4. So this is equal to L to the power minus 3. So the dimension of force is equal to L to the power minus 3. So here it is written minus 2. So this is not correct. The first option is not correct. Now let's move on to, we have to now find the dimension of linear momentum. I will write this equation, this one here, for the sake of reference. Now, the dimension of linear momentum. Now, linear momentum is equal to mass into velocity. So, the dimension will be m L t minus 1. So, this is the dimension, that dimension of linear momentum. Linear momentum dimension is equal to, this is, and this is equal to, now mass is dimensionless, so this will be equal to L, this is to the power 1, and t to the power minus 1. Now t here, the dimension of t is equal to L square, so t minus 1, this will be equal to L minus 2, and this is equal to L minus 1. Okay. So the dimension of force is L to the power minus 3, which, so the first option is incorrect. The second option is dimension of the linear momentum is L to the power minus 1. So we have got the dimension of linear moment as L to the power minus 1. So this option is correct. Okay. So this option is correct. So I will be writing the dimension. So the dimension of, I will be writing all the dimensions here, that the dimension of force was equal to dimension of of force was equal to L minus 3, first thing. And now I will be just rubbing it. And the dimension of linear momentum. So I will be just writing the dimension of linear momentum here. That is this is equal to L minus 1. Now we will find the dimension of energy. So you can take any form of energy for calculating the dimension. So right now I am taking the kinetic energy. Now the kinetic energy, the dimension of all the forms of energy will be the same. So you can take any form of energy here. So dimension of let's say kinetic energy. This is the kinetic energy is equal to half mv square. So this will be equal to m. Now v square is the dimension of this velocity is lt minus 1. So if I square it, this will be equal to L square t minus 2. So the dimension of kinetic energy is equal to this, or since all the forms of energy will have the same dimension, so using this using the formula for kinetic energy, I will be finding the dimension of the energy in this system of unit, which will be equal to m is dimensionless, L square. Now t minus 2, this will be equal to this will be equal to L minus 4. Okay, t, the dimension of t is equal to L square. So the dimension of t to the power minus 2 will be equal to L to the power minus 4. So this is equal to L minus 2. So the dimension of kinetic energy, here I will be writing it here now. Or you can say the dimension of energy. This will be equal to L minus 2. Okay? So the dimension of energy is L minus 2. So this third option is also correct. Okay? Now we will see the last option. The last option is we have to find the dimension of power. Now power is equal to, right, you can use this formula, that is work done upon time. Now work done is equal to force into displacement divided by time. So force, that the dimension of force is m. Force is equal to mass into acceleration. So m L t minus 2. Dimension of displacement is L, and divided by the dimension of time. So the dimension of power is equal to m L square t minus 3. Now m is dimensionless. Now t to the power minus 3. Now here the dimension of t is equal to L square. So the dimension of power in this system of unit will be equal to L square, because m is dimensionless. T to the power minus 3 will be equal to L to the power minus 6. So the dimension here, it will be equal to L to the power minus 4. Okay, so the dimension of power is equal to L to the power minus 4. Here it is written L to the power minus 5. So this option is not correct. So in this question, option B and C are correct. Okay. So now here the most important thing was that we were supposed to, since the dimension of mass and angular momentum in a particular system of unit was since mass and angular momentum in a particular system of unit were dimensionless, therefore the most important thing was to find the dimension of t in terms of L. So after we have found the dimension of T in terms of L, then we were able to find the dimension of force, linear momentum, energy and power separately, and we have found that the dimension of linear momentum is equal to L minus 1, which we have already found it here. I have written here on this board also, and the dimension of energy was also equal to L to the power minus 2. So option B and C are correct. And thank you very much for joining this session. I hope you have understood the solution of this question. In the next question, I will be coming up with the I will be taking up another question from the same chapter of units and measurement, and the question which I will be taking, it will be from the JEE advanced paper. So thank you very much. Till then, have a nice day. Bye.